We're going to talk about graphs in cubic and quartic polynomial functions. This is 11.6a. We've got 12 previous videos that are linked in the description. So graphs of first-degree polynomial functions are lines. And graphs of second-degree polynomial functions, you know those quadratic functions, they're parabolas. So now we're going to talk about polynomials of higher degree with real coefficients. There's third-degree or cubic polynomial functions, and their graphs have two curves and may have an S shape or it might flatten out in the middle. And there's fourth-degree or quartic polynomial functions, and they have a W or an M shape depending on if they open upwards or downwards, but these may also flatten out in the middle. So we have graphs of higher-degree polynomial functions. Every polynomial function has its domain, the set of real numbers. And the graph of any function is a continuous, unbroken curve that must pass the vertical line test. We learned about that in the beginning of Algebra 2 back in Chapter 3. It's video 3.3a. It's linked in this description. And unless a polynomial function is linear, no part of its graph is straight. That's important. Unless it's linear, no part of the graph is straight. It might have the slightest bit of curve that we could barely see, but it's not straight. A polynomial of degree n cannot have more than n real roots. This means that the graph can't cross the x-axis more than n times. A polynomial of degree n has n roots. And the polynomial x to the n exponent has only one root for any n greater than or equal to 1. So let's take a look at some graphs. Here's third-degree or cubic polynomial functions, and they have graphs like this. And look at this one. It crosses the x-axis 3 times, so there's 3 real roots. And this one, this is a cubic polynomial function, and so is this one. In both of these graphs, there's only one x-intercept, so there's only one real root for each one of these. See how they don't touch the x-axis except one time? Okay, look at this one. This graph crosses the x-axis once, and it touches it once. There's 2 real roots. And the general equation for a cubic is y equals ax to the third plus bx squared plus cx plus d. Now, do you notice the left and right ends of the graphs of an odd degree function go in opposite directions? Look at that. Every single one of them. The ends of the graph are going in opposite directions because it's an odd degree function. It's a 3. That's an odd number. It can cross the x-axis 3, 2, or 1 times. See that? We got 2, we got 1, we got 1, we got 3. All right? Graphs of fourth degree or quartic polynomial functions look like this. This one crosses the x-axis 4 times. So there's 4 real roots. This one, it touches the x-axis once. There's 1 real root. This one, it crosses the x-axis twice. There's 2 real roots. And for this one, it crosses the x-axis twice and touches it once. There's 3 real roots. And the general equation for a quartic is y equals, see now we have e at the end, and it's to the 4th here for our leading coefficient, isn't it? We've got ax to the 4th plus bx to the 3rd, cx squared plus dx plus e. Where this one, for the cubic, had ax to the 3rd, see? As its leading term. And for the quartic, the left and right ends of an even degree function go in the same direction. These are both going up. These are both going up, these are both going up, these are both going down. They're going in the same direction. It can cross the x-axis 4, 3, 2, or 1 times. We got 3, we got 2, we got 1, we got 4. See that? So that's a quartic. When multiple real roots occur, they occur at points like this, where it touches the x-axis. See? This one's opening downward and it's touching it. And this one's right at the origin. See that? There you go. Our next video is 11.6b, and we're going to actually graph polynomial functions. There's going to be links to those previous 12 videos and the one about the vertical line test 3.3a, all linked in this description. All right? I'll add this to the Algebra 2 playlist, and you'll be able to get to them a lot easier, okay? I want you to remember that I really need your support. You can go to patreon.com and become a monthly supporter for my free videos. And you can also go to PayPal or YouTube fan funding on my homepage. There's links in the description. Have a great day. I'll see you next video. Bye.